So, I'm going to give you guys some pointers on trying to solve problem 66 from chapter 4 in the online homework. In this problem, we're told that there's a person using a crutch and that we're asked to determine, or what we want to determine, is the maximum angle that the person can hold the crutch at relative to the vertical as shown in our picture here. What that maximum angle is that he can hold the crutch at without slipping. And all that we're given is the coefficient of static friction. So what we need to do in order to try to solve this problem is to look at a free body diagram for this person and the bottom of their crutch more particularly. So it's the bottom of the crutch right here that we're going to be looking at. So what forces do we have acting at that point? Well, we know that there's going to be a force from the crutch pushing down on the ground, which we'll call the force F, and we know that there's going to be a static force of friction preventing the crutch from slipping, and we know that there's also going to be a force normal from the ground perpendicular to the floor pushing up. So what we need to do then is label our axes for our problem, and if we want to try to use some of the forces to solve, we're going to need to break our force F into its vector components. And looking at this diagram, what we can observe is that this angle here will be the same angle theta given to us or asked for in the problem statement. So how can we break force F into its components? Well, as you can see from this drawing, or really let's redraw it over here, if we look at force F, then it's going to have a y component going in the negative y direction and an x component going in the positive x direction. And so we can use our components, or our trig functions, excuse me. I'm going to rewrite this f here since it got a little messed up, in terms of the trig function. So we know fx is going to be equal to f multiplied by the sine of the angle. Because again, this here is our angle theta. And then we can also see that Fy is going to be equal to our force F multiplied by the cosine of the angle. So, if we want to then look at the sum of our forces, we know that the bottom of the crutch should be in equilibrium. Being in equilibrium, that means that the sum of our forces in the x direction will be equal to 0, and the sum of our forces in the y direction will also be equal to 0. Alright, so what I want you guys to do from here is to go ahead and try to sum up your forces. The key thing that's going to help you solve this problem is to keep in mind the fact that we know that static force of friction is less than or equal to your coefficient of friction multiplied by your normal force. And if you're looking for the maximum angle, that means we're going to try to lean the crutch over as much as we possibly can before it starts to slip. So we're looking for the point at which our static force of friction is maximized. And so it will be maximum when it's equal to our coefficient of static friction multiplied by the normal force. Go ahead and give that a shot and let me know if you have additional questions.